Welcome, everyone. Thank you so much for joining me today. This is fantastic. So I'm going to be talking about creating scalable multiplayer experiences with Epic Online Services. Get ready. It's exciting. Now, so I'm Ryan Maloney. I am a senior online engineer on the Epic Online Services SDK team. I've been a programmer now for 20 years professionally. My amateur goes back to like Commodore 64, so it's been a long time. Not all that experience has been in gaming, so I've been in scientific computing, I've done some embedded computing, I do some performance engineering. Most recently, prior to Epic, I worked at a studio in upstate New York called Vicarious Visions with a long and storied history. We shipped Tony Hawk Remake 1 and 2, and then we became Blizzard, merged into Blizzard, where I shipped Diablo 2 Resurrected. So I was online networking for both of those teams, and I did a little bit of service on Diablo 2 Resurrected. So I do want to make the point, though, now that you've seen my background, this is really an engineering level presentation. So if you came in for slick marketing, you're probably going to be disappointed. I will do my best, though. I've got a couple of slides that are, I think have a little sizzle on them. There will be QA at the end. I'm happy to answer everyone's questions, but please just hold them, and we'll do a session at the end of the talk. And I also do want to have a call out to the many people that helped turn what is a pile of programmer art into the presentation you see in front of you. And it is fantastic. We are all better off for their efforts, I assure you, because I have no artistic talent and am also colorblind. So this is a way better experience. So first, I'm going to try to structure this talk so that I can set up the context so all of us understand all of these talking points. So let's talk about Epic Online Services first. Now, I know I said there wouldn't be slick marketing, and here we've got one slick marketing slide. That's up there. I'm not going to read it to you. Epic Online Services is a collection of services that you as developers can use to implement the back end of your game, okay? Now, the design of these services was informed by lessons learned from Fortnite, also from Gears of War and other Epic experiences. But the services themselves are intended to be used generically across game experiences. They don't enforce one particular pattern, one particular model. They're flexible, and that's intentionally how they were designed. They're also scalable. And now when I say scalable, I mean we scale them. You as developers aren't doing anything other than using them, and they scale for what you'll see as magically. They are intended to enable cross-platform play. So these are services that we want you to use cross-platform. That includes mobile and console. And this is the big selling point. They're free. And I mean free. I don't have any asterisks on there. They're just free. So let's just take a look. When I talk about Epic Online Services, how many services am I talking about? There's a lot. So these are the kind of services you're going to use as you go to build out your game, at least for your back end. There's things up here like anti-cheat. There's things like presence. We have, all of these categories under moderation. We have voice chat. I'm not going to talk about all these today because it would be a very, very long presentation, and none of you have time for that. So today I'm focusing on the multiplayer section. Okay, so that's the sessions service, lobbies, voice chat, and peer-to-peer. So let's just, as you see in this diagram, we have the distinction between game services, which is what I'm primarily focused on today, and Epic account services. So let's just talk about this before we get any further, because I know sometimes there's confusion of the two. So the game services I'm talking about today are there to support your game multiplayer needs. Things like matchmaking, things like voice chat, peer-to-peer for direct connecting two different game clients. Okay, there's not a part of that is social. So account services is a separate set of services that require an Epic account. Game services that I'm talking about do not require an Epic account. There are some interesting integrations with Epic account services that I will show, but game services are intended to work standalone, fully functional without using an Epic account. So I just want to make sure, because sometimes there's confusion, there's no bait and switch, no nothing. This is, they're fully functional as is. So how, as a developer, are you going to access the Epic Online services? So this is, of course, the team that I work on. Epic provides an SDK. Now, the SDK provides a C API. We do have a C# API. And this library is intended to be used not just in Unreal, not just in Unity, but in any game engine, right? You can make any binding you want to it because it's C. It is cross-platform, and again, that includes mobile and console. Okay, Unreal Engine, I want to highlight, not required. There are, however, plugins for Unreal and also for Unity. And I did make a little note there because there are other APIs that are actually web accessible, but I'm not talking about those today. So everything we're going to talk about today, you'd access through this SDK. So let's get into it, all right? We're going to talk about multiplayer services today. And these are the ones that we've kind of highlighted and that I've used for today because these are the ones that, in my experience, are typically used to enable multiplayer experiences. So we're going to cover sessions, lobbies, and I'm going to group voice chat under lobbies, even though voice chat is its own separate service with its separate set of APIs. For our conversation today, we're going to talk about the integration with lobbies. And then we're going to talk about, near and dear to my heart, peer-to-peer. So some of these use cases are going to involve advertising and discovering player matches. We're going to talk about gathering groups together for joint matchmaking. We're going to talk about how you might use voice chat in those integrations. And then we're going to talk about connecting peers across different private networks with peer-to-peer. Now, I do want to say these examples are not exhaustive. I chose some examples that are a little simplified, right? And I don't want you to think that because one of the examples, doesn't match what you're doing, or I didn't talk about it. These game services are designed to be incredibly flexible. So these are just some examples to get all of us thinking and to drive home some of the best practices and tips I'm going to cover. So before we get too deep, in order to use game services, you do need to authenticate, but you need to authenticate with Epic Connect. Now, this Connect interface that we expose through the SDK, that uses any number of identity providers. We have several, of which Epic is one, but it is not the only. So there is some, I put the SDK code here. There's no quiz, no one needs to memorize it. It's all in our docs, but it looked fancy, right? We got to look fancy. So before I again, let's keep establishing that context. My experience is there's a lot of confusion between sessions and lobbies. And it's completely understandable. I've had those as soon as I started as well because they actually overlap with most of their features. And the APIs look very similar other than naming differences. So, they both support searching. They both support invitations. They both have customizable attributes. They both work on game clients. They both work cross-platform, which is very important. And they both support what we call internally presence join. That's actually part of the API, I should say. But the idea of presence join is that a session or a lobby can be joined directly if you have its ID. And we call it presence join because typically the ID for one of those would be shared in a player's presence. And anyone, a friend who can see that presence, is then able to join their session or lobby. They do have different data models, though, which we are going to get into because they are different in very important ways. And there's a couple other features in lobbies that we're going to have to get into because they are important for matchmaking. However, it is important to note that lobbies are not supported on dedicated servers. Also, I want to point out that you can use lobbies and sessions together, right? They work separately, they work together, they're not mutually exclusive. Peanut butter and jelly, right? Peanut butter's good, jelly's good, peanut butter and jelly's good. So just, I see a lot of should I use one or the other? You can use both. It's going to depend on your use case, and we're going to walk through some of them. Okay, so I hope everyone has the context. We know where we're at. Now let's start doing a little bit of a deeper dive into sessions. So we're going to start with the sessions interface. So the sessions service is all HTTP request-based. So the game client sends a request up to the session service, and it gets a response. Straightforward, right? We've already touched on this. Sessions do support both game clients and dedicated servers. So you can use listen servers, you can use dedicated servers. They support, you can find by unique ID, you can search for sessions. They do support invites, and those invites do not require an Epic account. And they also support customizable attributes, which are also searchable. So you can create a session and add your own attributes and customize and then have your players search on those. So hopefully this sounds good, right? Let's start diving a little bit deeper into sessions. So I've got again, thanks to everyone who made this look so good from programmer art. You would not want to have seen the original version. But let's talk about a very simple case here just to get us all on the same page. Okay, we have a game host. All right, the game host is advertising a game. In this case, it's creating a session on Epic Online Services on the back end. And when it creates that session, it adds some information to the session. It says, hey, this is the game type and the game mode associated with this session. Here's the address of the server that hosts the session, and here's the maximum number of players allowed to play this game. These are like the basics you would have in a session, so you have enough metadata to make a decision of whether or not I want to try to travel to this server, right? And then we have the game client, which is able to discover the game by actually searching by that ID, getting that session information, and using the session information it's pulled from the EOS backend to resolve the address for the server and then travel to the server. So, should be fairly straightforward. I will add that I did a little bit of like mislead here insofar as I haven't shared how the actual session ID would get to the game client. We're gonna just elide that detail for now. We'll talk about that a little bit more as we get on. But just, for us to round up, we essentially have a very simple case of a game host advertising, a game client attempting to find. So when the host creates a session, there's two things I want everyone to keep in mind. It is very important. When you create a session, there's a bucket ID. Now the bucket ID field is required, and I've seen it. Some folks will just kind of put a value in there, right? I'm not going to say like default, but bucket ID is actually quite powerful because the backend uses that to partition dedicated servers, and that will improve your search considerably. So please, when you go to use a bucket ID, please use one that maps well into your game. So a good example is like region, for instance, right? Using Fortnite as an example, a good partition point could be Battle Royale and Zero Build, because those are essentially mutually exclusive from a player perspective. I'm not, as a player, ever going to say, oh, I need a game that's both a Battle Royale and Zero Build. So if you can find those partition points in your game, you can break those servers up, and then the backend is able, when you run a search, the backend is able to bucket that search. However, in order to get that, you do need to specify that bucket ID whenever you execute a search. I actually put this up here because, again, not a quiz, you don't have to memorize, but I had forgotten that it wasn't a top-level part of our API. So when you do go to execute a search, there's a special like restricted field that you use to specify the bucket ID. The backend picks up on it and then uses it to perform the search. We'll mention it again later, but I want to point it out because it's really quite powerful and I do think it's underutilized. The other thing is, please keep in mind the permission level of your sessions. So by default, sessions and of course lobbies, but sessions are created as public. So the permission level affects both the joinability and the discoverability. So a public session is discoverable by anyone and joinable by anyone, which might be what you want. For our example, we probably want what's called the presence level permission, which essentially means anyone who has the ID of this session can join it directly. And that gives you that sort of ability to put your session ID in a presence and say, well, if you can get at that player's presence, then you can get into there. And so that's a very powerful level. Now, the most restrictive is invite only. So a session that is invite only can only be joined and can only be discovered by someone who has been invited to the session. Now, I want to point out, and this is also a common point of confusion, including with myself, anyone who is a member of the session can invite. So it is not just the owner, and there is no setting for that. So as soon as as soon as a player becomes a member of a session, they now have permission to invite others. So we've created a session. Game host has it. It's on the back end. Now we want to find it. So we've got a nice simple case here. And the nice thing about this case is that the game client is finding by session ID, which is essentially a globally unique ID, which is great because you're going to get the best search performance. It's not even a search, right? You're just a direct lookup. Awesome, best performance you can get. Really not convenient for the player or potentially for the developers. So for this case, we're going to get into this a little bit more, but just know right now that a find by ID is going to be highly performant. Now in this case, you'd have to then say, well, the game host is going to share this unique ID. Maybe you do it through Discord or send a text. Sometimes a game UI, we have folks that'll show it in a game UI and say, hey, tell your friend to go join on this. But this, again, takeaway, find high performant. So now you have your session that's been created. Game host has got it. The game client has now found it and wants to join it. So this is actually a point of confusion I had when I first started, given how our API is named. So this is the join session SDK API call. Now, the name is misleading because what it really does is check joinability. It does not join the player to the session. So it doesn't reserve a spot for the player. All right, so the question is, and as you can see here, I've got my nice diagram. Look, oh yeah, here we are. So essentially, join session has the game client say, am I able to join the session, yes or no? And then our workflow, which you'd have to implement though, is we don't want to travel until we know that the session is joinable. Why? Right? Why have something even this method? So what the case we're trying to prevent is in the absence of this method, the game client here is going to travel to the game host. The game host has to check and say, I don't have room, and boot you out. So we're trying to save that hop because if the game client checks on Epic Online Services and the session is full, it won't waste time traveling. So ideally, this check session, the joinability check, is to prevent all this unnecessary travel and unnecessary work on the game host. Now, the conditions under which a session might not be joinable, right? If Epic Online Services has the session as full. So if the maximum number of players is 4 and there are 4 registered players, that session will come back as not joinable. If the session is set to enforce sanctions, now I can't talk about sanctions today, I don't have enough time unfortunately, but you can actually set sessions as being sanction enforcing. If they are and the player is sanctioned, they will not be able to join, or they'll get a non-joinable back. We're also going to talk a little bit about join in progress. So if the session has been started, which indicates that a match is running, and it's not allowing join in progress, it'll come back as joinable false. Also, if the session is invite only and the player doesn't have an invite, they also will not be allowed to join the session. So, how do we actually get players into a session? That's the next question. And this is through the API register player. So register player, you want to have once the players are in a match. So in our case now here, we have a game host that's in match. The game client has traveled, and the game host, which is the authority on the state, says you may join. So the game host had room, the game client joined up, and then the game host registers that player. And when they register that player, it tells the back end, great, I now have a new player in the session, and the back end can update the player count. That's the point at which the player associated with the game client is officially registered with the session. So I think there's 2 things to consider here. One, I want to emphasize, the game host, that server, is always authoritative on state. So this session could say, oh, there's 1 spot available. Well, if 3 players all check, and they each say 1 spot left, and all 3 attempt to travel, 2 of them are going to get rejected. And so it's up to the game host to enforce that. We can't do it from the session side. So the game host is always authoritative on state. And the game host, being authoritative, should not register a player until the player is officially in the match. They should also make sure they unregister a player whenever that player leaves. So we've covered, I just want to make sure the atomicity of it is, has caused some confusion in the past. Now, I also want to highlight something else here. You'll see once the game host registers the player count on the back end shows that the player is registered. But the game client, they have a local view of the session, and their session is out of date. It only shows 1 player. Okay, so we're going to talk about the data replication model in sessions, because this is important as well. So as I mentioned, session owner is always authoritative on session state, but session members have a local copy of the session. So each member has a view of the session. They are responsible for keeping it up to date. The session members don't have the authority to update the back-end state. Now, what this means is that when the session state changes, the game host is responsible for notifying the session members so that they can update their local session state. Right, so if we look here, right here, each of these clients have the state of the session as it looked when they joined. And so what really has to happen is this host right here has to send a notification to client 1 and client 2 that says, hey, by the way, another person just started. If you look in Unreal Engine and some of the online integration, that's actually what happens. So essentially when the game host, when one of the servers gets it, they send a data over the data traffic, they send over a note that says, hey, the match has started. And then each client that's in the session will then update their own local session state so that each one stays in sync. So it is important to do this. We don't enforce it. The reason why I tell all of you today is that at an EOS SDK level, we can't enforce it for your game. You have to. So we've got the data replication model. We now have a host that's created a session. We have a client that's found and joined it. And now we're ready to start the match. So what does the game host have to do? They've registered the players, the match is starting, and what we want the game host to do is to use the start session API to tell the EOS backend that the match is now in progression. So once we know that the match is in progress, we can then, if someone else does a search on the backend, it'll be filtered out. So we'll say, hey, this match has been started, and it's not joined in progress, so we won't even send it to you in a search result, which is great. You're essentially getting automatic filtering on this. But the important part, though, in order to get that auto filtering is the game host has to be sure that the session state stays in sync. I will say, too, just anecdotally, so on a previous project, we had dedicated servers that ran for long periods of time, and they cycled through playlists. And so as these servers cycle through playlists, they could maintain very long-running sessions. And you can just start and stop the session for really indefinitely. So there's no reason that starting a session has to end a session. You can continue to start and stop throughout its lifetime. And again, this is another, I think I've explicitly had this here, but whenever the game host starts the session, the game clients should as well, just to make sure that all the local session state stays in sync. And this is, I know, a simple one, but just because I want to be complete, and it does make a difference, it's important to shut down a session once it's done. So there is a stale session cleanup built into Epic Online Services. This is to handle cases where a game host was hosting a session and they crashed, or the network got lost. And so stale sessions are picked up, but there is a heartbeat, which means that there's a window of time during which that session could be searchable even though the host is gone. And so we try to minimize that wherever possible, please, because it's good for your search results. So if possible, please don't rely on that heartbeat. Destroy the session explicitly. Now, we'll take a bit of a breather here. So we did the simple case, which I like. It's the classic one, right? We're going to just find, we've got a host, share an ID, we find it using the back end, brokers and messages. This one is one of my favorites, right? Which is the classic session browser. Now, I'm sure, everyone in here has probably at some point or another used a version of this. Big game hunters in StarCraft, new modern games use it. It's a very flexible system. And so I've got it here just for completeness, right? But a game host all advertise a session. There's many sessions available. Your game client goes out and says, hey, I want a bunch of these, and then I'm going to show them to my user in a browser so they can choose which one they want. Typically, there's some metadata in there that indicates, oh, well, we're on this mode, or this many people are here, or this is the level, or this is what we're doing. I will say that filtering in this case can really happen either way. So the session search capabilities are quite significant. You can search on attributes. You could even set some attributes on your sessions to be visible for search or potentially not, depending on how you want to do it. You've got your bucket ID to partition up all the space. You can also filter some on the client side. So this allows a mix of that. And again, I put it here, but please use bucket ID. This is the area where bucket ID is really going to help you, right? Because almost certainly when someone does a session browser, you can almost certainly bucket on region, right? If I'm in the US, I don't really want to see, EU servers. So that's usually a freebie. So yes, talking about find, right? I already said bucket ID. Please specify the maximum search results. The large amount of search results we will return caps out at 200. For a session browser, my guess is by the time the users make it through the top 15, the rest of the results are going to be stale anyway. So there may be some circumstances around here, but think carefully about how much you really need. And again, this is for the benefit of there's no need to pull, 150 records if the users are only going to look at 50. So think about what your players are doing. This is really a very important point, and I think this has caused a lot of confusion, including again with me, so I want to make sure it's clear. We don't support, sorry, hang on. There we go. We don't support pagination. So the way this works is when you ask and say, I would like, as a game client, as a player, I'm searching for this many sessions. Okay, let's say you're saying I'm searching for 50 sessions. A random subset of the sessions that match your filter criteria up to 50 are returned. So if you call that again, you don't get the next page, you get another random subset of 50. Now this is intentional. The reason this is here is from some lessons learned, I believe especially from Gears, which is what will happen often is imagine you have many game clients that all search for the same results. They all pull the same 50 results, and then all of them try immediately to get into the top 10. And so you get a whole bunch of people, they all get rejected out of travel. So the idea was we've added some jitter to it. It does cause some confusion though, because what will happen is we have seen this, is players will say, I just want to keep searching until I get the server I'm looking for. And you may never get it because it's a random subset. Which brings me to another point. Please be very, very careful about exposing elements on a UI that allow players to execute searches against our backend. Please, we want to at least debounce that on the client side. Again, we have protection we can implement in terms of rate limiting, but it's really not a great experience because the players tend to get frustrated anyway. They're looking for a server and that's not working for them, and it creates a lot of unnecessary traffic. So it's sort of a lose-lose. So please just be cognizant of that. Okay, so I'm going to take a little break here and we're going to talk. So we've talked about sessions. We've talked about creating them and joining them and registering and finding. We've talked about Session Browser. However, one of the things that all of us want to do is play with our friends, right? And so the question is, how does Sessions integrate with a social graph? Now, I've already said once before, so with Sessions, they support invitations. The invitations do not require Epic accounts. We'll talk about the API in a little bit. And there's also a custom invite system we support that is not tied to Sessions that allows you to send invitations to players with custom payloads, brokered through Epic Online Services. So there, again, does not require Epic accounts. Both of these integrate with the social overlay. So I am going to show some examples of how this integrates into Epic Social Overlay. But I do want to emphasize, it is not required for Sessions. This is just our social overlay benefits from this integration. I want to share an example of what one looks like. And so now we have just a brief. So now we're talking about the social overlay. For Epic account services and using social overlay, you'll have to authenticate there. Again, you're not going to be quizzed. I just wanted to show, look, we got some fancy SDK code up here. It looks sharp. But this is just a note that we're talking about the social overlay now. It's an Epic account service. Everything on the up and up. Okay, so this is a picture over here. This is a screenshot of the Epic social overlay. And you'll see right here, this has nice integrations for accepting a game invite. You can send invites. This is for join on presence. And if you look here, just while I'm pointing this out, there's integration with native platforms. And so if players have linked their native platform account to their Epic account, you'll actually see evidence of that. So again, this is an example of what it would look like to integrate the existing game invitation into a social graph. Okay? So now let's talk about invitations generally. Just an example, want to get everybody on the same page. We're going to talk generically about invitations, right? So if we're in session again, we only need game services. We've got a game host, right? Maybe it's a listen server. They want their friend to join. They know their friend, and so they're going to invite their friend directly. So when they invite their friend directly, this sends an invite that is, again, brokered right through Epic Online Services, and the invite's going to be pushed to the game client. And that invite actually includes the session information with it. So this is great, right? Now you're able to get a game host that has a session with a very restrictive visibility level. So if you're looking to keep that session such that other players can't join it without an invite, now you've got that level of protection. And the game client itself doesn't have to search because the invite comes in with the session information. So now you've saved yourself a lookup. So it's great. This is, if you're looking for an invite system, you've got it. The one thing I do want to highlight, I know I mentioned it earlier, any member of a session may send an invite. So that is important to note. So here's a quick look, I promised it. So here's a couple methods off or functions off of our session invitation API. So you can send invites and you can hook for notifications when they're received. So you can actually say, hey, I want to know when an invite comes in. You can query invites, so you know when you can actually query and say how many invites has this person received. I do want to point out, and one of the reasons actually I'm going to make a quick note. I made a note to myself specifically for this. There is a reject invite function on there, which is fine. That's typically used for housekeeping. I don't want to imply that giving people like, your friend rejected your invite is a good idea. That's not really a good idea. That wasn't the intention of the API. So I know that's probably common sense, but I just want to make that point explicit. The other one is session invites belong to the session, which is unintuitive for many folks, including me. There's some back-end design reasons for that. But that means that if, let's say I'm in a session and I have a friend in a session and we both invite a third person, that person is going to get the same invite twice. So it's not, he doesn't get one invite from me to the session and another invite, he gets one. And so if he accepts that invite, technically he's accepted both of ours. So some of the, we've worked around that for our own social overlay a little bit, but it is something to note in behavior. Because I know it's unintuitive. When it happens the first time, you're like, I accepted Ryan's invite, but why did the other one disappear? Because they're one and the same. Okay. All right, so we spent a lot of time in sessions. I'm hoping everyone has at least a pretty good feel on how sessions work and a little bit on the API and a bit of a taste of that, because I want to be able to compare them now to some of the big differences with lobbies. All right, so if everyone's ready, deep breath. Lobbies, okay. So they share a lot of the same behavior with sessions. So you can create, we'll talk about some of the relative differences on create, the relevant differences. Find and search, just like we talked about, same concerns about bucket ID. There's invitations, just as we discussed, right? So lobby supports invitations, only needs connect. But let's think about some of the areas they differ, because that's where things are going to get interesting. Now, the lobby, actually, each player's lobby in a game client maintains a persistent connection to the lobby service hosted within EOS. Okay, that's a secure WebSocket connection. Now, that connection is essentially brokered through Epic Online Services. So there is no NAT involved, there's no NAT punch, it's a connection directly through the WebSocket. So you essentially get every member of a lobby has a persistent data connection to the service, okay? It's quite powerful. We're going to talk about some of that as we get on. Specifically, data replication, because now you've got a new means for replicating data across your lobby members. Lobbies also have integration with voice chat, and that is cross-platform. So that's great. You can have your voice chat room live for the life of your lobby, and as people join in, they can join into the voice chat room. It also will respect platform-specific restrictions on voice chat. So we do have native integration for that. Lobby also support member-level attributes in addition to top-level attributes. So sessions had customizable attributes. Lobbies have customizable member attributes. The only thing to know about this is that lobbies, again, as we mentioned earlier, only supports game clients, like listen servers, for instance. So there is no dedicated server support. Part of that is the use of voice chat integration. You don't really need voice chat integration on a dedicated server. So let's just talk about now, how can we employ lobbies? Let's up the stakes on our examples here a little bit. We're going to talk about group matchmaking. So basically, I think we've all at this point most likely played a game where we grouped up first. So we want to get together as a group, get our friends together, and then we want to look for a match as a group, right? And part of the benefit of that is once you get everyone together in a group, you can do that decision-making process of like, what game are we going to play? So the lobby host and the players in a game gather in a lobby, right? And the same way you get into a lobby would be the same way that we were talking about with sessions. You might give someone your lobby ID. Your lobby ID might be in your presence. You might send them an invite. It might just be public and people are looking for it. So whatever it is, they get together in the lobby. Now, the lobby host is going to change the game mode, right? You can imagine this with Fortnite. We're zero build, right? Now, that lobby host then pushes that information out to the clients, and then the clients get an update like, hey, the lobby mode is now, the game mode we're playing is 0 build. And so you can see here in my little diagram, right? This change mode comes out and it actually pushes that immediately to the lobby members. So compare that to the data replication model of sessions, where you essentially, the host is responsible for pushing to the lobby member. That's gone now, right? Because now Epic Online Services is taking care of that for you. So, brief interlude here. When creating a lobby, very similar to sessions, keep in mind permissions, same restrictions as before. Keep in mind bucket ID. You can disable voice chat if you want. I mentioned the room exists with the lobby, but there are a lot of additional APIs we have to talk about. I'm sorry, I had to cut some of this out of the presentation because we'll be here all day. But it is important to note you do have an integration with that, and it is quite handy to have voice chat live with the lifespan of the lobby. Lobby also has host migration, which for anyone who's had to do this before, it's very difficult to write because it's essentially a distributed consensus algorithm. We've got it. So if you can turn it off if for some reason you'd like to, but the lobby is designed so that if the person who created the lobby drops out, another member will be promoted automatically. That happens over data replication. You don't even have to opt in, it's on by default. So you have to opt out. I think it's a great feature. I'm sure as with everything we build, I'm sure someone will come up with a use case like, well, it messes with this. That's fine, you can turn it off. We're there for you. But I think it's a great feature. It also has a very special join by ID field I want to call out. It has a particular API method that's unique. And what this allows you to do, again, more flexibility for the developers, is you can set the lobby level to invite only. And technically what that would mean is someone who didn't send an invite, who didn't have an invite, couldn't see it. But if you do that, if you send your own invite system and your invite system uses this custom API, we'll allow that. So essentially you're saying, hey, I want this to be an invite-only lobby, but I can send my own custom information and I'm going to use this specific API. So it adds a lot of flexibility for lobby and for invitations if you don't want to use the built-in invite system. Again, I want to emphasize, we are writing, all of this work is to make your lives easier as developers. We are looking to learn our lessons. We want to help. So I've talked about lobby data replication. It's great. I can't really say enough about this, right? I had to roll a peer-to-peer system to try to do this, and it was absolutely miserable and costs some real time and certification. So state changes. Whenever the lobby host changes the state, it gets pushed to all members. So if the lobby host changes a attribute in the lobby, it goes out. If a new host if the lobby owner promotes a new host explicitly, all the replication happens automatically. You do not call anything on an API. Your owner of your lobby calls update, and the rest gets handled. Member attributes are specific, so individual lobby members can update their own member attributes, and they will get passed to other members of the lobby. So this is how you can say, hey, I want to have a lobby, and I'm changing everyone's skins, and I want everyone else to see each other's skins. There you go, right? You can change your lobby member attribute as a player. That gets pushed out. Everybody sees your new skin. I will add a note here. People are very clever, and I love them for it. This replication is not meant for game traffic. I know some of you are thinking it, and I don't blame you, and I keep telling people, this is a great feature, please use it, but definitely not for game traffic. The latency isn't meant for that. But I appreciate all of you probably thinking it in the back of your head. So let's talk about this sort of group matchmaking, right? When you go to join a lobby, there is no join versus register distinction like we had with sessions. When you join a lobby, you join it. So unlike there's no check for joinability, you try to join it and it won't work, or you join it and it does work and you're done. The existing lobby members, now the other thing you'll notice with sessions is when a new member joined, other members didn't get an immediate notification because the session host would have to send it to them. Well, this happens automatically now. So if I'm already in a lobby, I'm in a lobby and my buddy joins, I already see him join my lobby because now the EOS pushes an update down. So if I'm using the SDK, I'm going to go ahead and get a lobby member update, and I'm going to know immediately that a new person joined my lobby. Also, like sessions, again, I know it's kind of tedious, but please clean up lobbies when you're done with them. There is, again, heartbeats. Lobbies actually have some very potent retry code so that we can live past minor glitches of oh, whoops, we had a network outage for 15 seconds, now we're back. So please leave it explicitly. It will be cleaned up, but it's much better if you keep the back end in an accurate state. Much better for your searches. So in this case, now, I mentioned we could have lobbies and sessions. Perfect example of lobbies and sessions, right? So now we have the lobby host over here. So they're all in a lobby, everybody's good, but they don't have a session yet. So the owner goes, hey, can I find a session? Got it, great. And then it says, hey, let's update the lobby with that session ID, and now the lobby member has the session as well. So basically the lobby host here can update, can look for a dedicated server session or a listen server session, get that ID, and then broadcast it using the lobby attributes to the members. So now you can still use your sessions to actually represent a dedicated server on your back end, but allow grouping in the lobby to find that session and then pass that information to all the other members in the lobby. It's really quite a powerful combination. Now, I should add too, I made a note of this. This does not talk about monolithic matchmaking. Some of you might be using monolithic matchmaking. In this case, there's another service here that essentially finds the session, right? Instead of this session search bit, there would be something like, hello, monolithic matchmaker, I have a lobby member, here's some information, please go find us a session. So essentially, this would differ right here, who's finding the session. But I can't really discuss more of that in this, we can talk about it after, but now I can't keep it in this presentation. Okay, peer-to-peer. Let's talk about actually connecting players together, as opposed to grouping them together for connection. First option, dedicated servers, right? It's a great one. There's a lot to be said for using authoritative servers. Dedicated servers are publicly addressable. It's great. Everyone connects to a single server. You've got, many libraries for reliable UDP. It's great. Downside is that dedicated servers are expensive to maintain. They are expensive to run. And so that's not always the right solution. And so in some cases where we want to directly connect peers, we have peer-to-peer. Very powerful. You can have player-hosted matches, right? The issue, of course, is that players are on private networks. And private networks, especially ones players on, are built with whatever consumer hardware has been available for the last, sometimes 15 years. So you never know. You're going to have varied NAT settings. You're going to have people that, the hardware itself might have bugs in it, so you just never know. It is really quite challenging. And I guess here, quickly, you've seen, right? This is the typical private network, right? And it's like, how do I get through here? And I guess the question you ask, Ryan, is how challenging? It's really challenging. So for those of you who haven't done it, it's got a lot, there's a lot to it. It does actually require client and server-side components working together, right? Because you need a client-side library. That library has to be cross-platform, by the way. And your server-side, which is going to be used to actually coordinate between those peers. And that has to scale because that's going to handle game traffic. So it is a significant effort. In the next few slides, I'm going to cover the details of our peer-to-peer implementation, okay? But I want to highlight, we've got one API call that hides all this away. So you don't have to do any of this. Peer-to-peer does it all automatically. It does work cross-platform. That includes on mobile. We're just running some tests on that on Friday. It does work when peers are behind private networks. It even works when they're behind strict NATs. And again, single API call, send packet is what handles this. So signaling, right? The first part of peer-to-peer connectivity, right? Two peers are behind a private network and we need to get a connection between them. And so they're going to say, I have to have a path to negotiate our connection. And of course, that path can't be through each other, so they need a third service. So this signaling service is hosted on Epic Online. And again, it's like, well, we need a connection to create one. That's why you've got this broker. Our implementation wraps actually WebRTC, which is a well-known open source library. And so this library basically allows two peers. So peer A says, hey, I've now discovered all of the IP addresses that I have locally. And it says, give it to EOS, and EOS will push it to the next peer and say, hey, peer A has this many IP addresses. And that way peer B can actually test all of those IP addresses and say, which one can I use to connect to peer A? Which is great, but they're all going to be private. So that's not really going to work very well, right? What we then need is stun. And so stun allows public IP address discovery. So what each peer does in this case is, now you'll notice these peers both have the same private IP addresses. So if they tried to connect to private IP addresses, it would be ineffective / comical. So each of them actually connects to a Stun server, also hosted in Epic Online Services, which come back and says, hey, this is your public-facing IP. This is what you look like to the world. And by the way, we detected your NAT type, and it's non-symmetric, which is good for us. So this information comes from Stun. And so what happens is each peer now has their public IP address, and they can share that with the other peer. And the very act of making this call should hopefully, unless the NAT is symmetric, have opened the port in NAT so that they can accept an incoming connection. It's great. We consider, just so you know, for us, a symmetric NAT is considered strict. You can call like there's a whole, again, that's another one I could spend a whole half a presentation on NATs, and I don't think anyone would find that terribly interesting. So we've got peer A and peer B. They were able to exchange public IP addresses. All is good. Well, unless they're both strict NATs, and then that's not going to work either. And so when we get to this scenario, there's actually what we call, this is turn. And so we have to relay the traffic from peer A to peer B through another relay service. Now that's game traffic we have to relay. So in this case, if I go back, eventually we would be able to send traffic directly between them. But in some cases with this strict NAT, you actually have to relay all the peer traffic through here. Now it's important to note that this is an extra hop, so latency is involved here, which means that we also have some regionality to these turn servers to try to reduce that latency overhead. So in cases where we detect a strict NAT is involved, it will automatically relay the traffic through our servers to the other peer. Now, by default, we use an SDK. Everything is set to allow. And allow basically says, only use a relay if I can't make a connection. You can set it to force. We do default that on Series X because there is some of you may be familiar, but there's a Microsoft cert requirement that did prevent directly connecting to an Xbox Series X. That cert requirement has been retired. We keep this set up for consistency, although the future of that, it's something I'm debating right now. But most platforms are going to be this all allow setting. And for most normal cases, that's probably what you want. For very, very latency sensitive games, something like pretty twitchy, I'd say talk to me after. We might have to have some more conversation about that. So make sure I'll leave time for everybody. So final considerations. I've talked about a lot of multiplayer services today. I want to emphasize that these services are intended to help you. We have built these from lessons we've learned, but it's not to push any particular pattern on anybody. We want to enable your multiplayer experience, whatever that might be. The sessions are designed to be flexible. Lobbies are designed to give you that sort of connectivity, all of it cross-platform. Peer-to-peer is there to take care of all of these edge cases I just showed you that are quite thorny to deal with. We really are committed to helping you and enabling your multiplayer experiences. So again, cross-platform is a big deal for us, right? This is something we test everything cross-platform. We are intending these services to connect players cross-platform. We think cross-platform, it's just how we are. So, I've got some documentation up here. You can just take a look at it. You obviously can find it on the web. I'm going to be at our booth. I'll be around. You're more than welcome to ask questions. And so I want to thank all of you for your patience, and I really appreciate it.